3, 2, 1. Alright. What we have is what's called exponential function. Now the exponential button in your calculator is, you can see it here, it's e, okay? Now e on its own, e to the power 1 is the number 2.718. Now you might say, what is the function of this button? Why do we just have a random number? Now this number, we've done it before in the first chapter. What it's used to do is, it's linked to logarithm functions, and it's used to monitor growths of, so for instance, if this was population growth, there's a formula that has e to the power of something in it, and it gives you population growth, stock growths. It's very used, it's a widely renowned number used in all sorts of industries. Physics, maths, business, everything. Population analysis, everything, okay? Now, what we gotta do is we're gonna do a bit of differentiation on it, okay? Now, it's actually quite an easy rule to get right, okay? If y equals e to the 4x, one thing you've been guaranteed every time, you're guaranteed this. When you differentiate it, what will always happen is what you had originally will still be there, unchanged. So the only thing you got to worry about is what is in this position here. And whatever is in this position, you differentiate it and you put the derivative at the front. So what's the derivative of 4x? 4. So the answer to the first one is 4 e to the 4x. Okay, next question on would be number like, for example, number 2. Okay, you get 2 e to the 3x, okay? Once again, you're only worrying about what's here. You differentiate. Exactly. 2 multiplied by 3, because the 3 goes to the front, it stays the same, and it goes 6 e to the 3x. Quite simple. Okay? Now, it gets a bit harder when you get to the likes of number 5. So I've done 2, 1, 2. I'm going to go for number 5 now, okay? Now, in the case of number 5, okay, what we get is y equals e to the 4x squared, okay? The y dx ends up to be e to the 4x squared, guaranteed. Whatever's in the power, differentiate it and you get 8x. 8x e to the 4x squared. Is that right? Now that that's done, we're going to go more difficult again. Now, an example of a more difficult one again would be 11, which has tan x in it. Y equals e to the 4 tan x. Shane. Now, what happens here, guys, once again, when you differentiate, what's guaranteed is that your original question survives to the next stage. Now, what you have to do next is you have to differentiate what the power is. And when you differentiate what this is, okay, you're going to get the, just going to bring it down here, right? The d dx, differentiate with respect to x, 4 tan x. Now, in your notes, it will say 4 goes straight through. The number in front of the variable always goes straight through. And then, what happens when you differentiate tan x? Secant squared x, okay? Now, we discussed this yesterday. Secant x is 1 over cos x. Therefore, secant squared x is 1 over cos squared x. So 4 secant squared x is going to be 4 over cos squared x. And all we got to do there is, that part we just did there a second ago, we're just going to bring it up here, and there's our answer. Okay? Now, moving on again, we're going to go to a more difficult one again, okay? This one actually, quite tough. Okay? Number 12. Now number 12 is an odd one, okay? It's y e to the x sine x. Once again, what can we be guaranteed about the first derivative for number 12? e to the x sine x. Okay? Then after that, we have to differentiate x sine x. Now, guys, what type of rule am I going to use for x sine x? Product. Because
so it would be x.
I'll have to do it out, I'm afraid. Okay, so I'm going to get dy dx. Oh, sorry, not dy dx. This is just for the. This is purely for the product rule. We're just going to take it down and do it separately. Okay. So u equals x, du dx therefore equals 1. Phi equals sine x, therefore dv dx must be cos x. Fill in the product rule. U times dv dx, which is going to be x times cos x. Phi times du dx, which is going to be sine x times 1, and it's going to be x cos x plus sine x, all in brackets. And once I have that done, what happens is just slots in to the front, and there's your answer to the full thing. This full thing here. Okay, let's go again with number. Excuse me. Okay, guys. What we're going to do next is some of the ones that are a bit more difficult. Excuse me, guys. Okay, so what we're going to do next is we're going to say number 18, okay? Number 18. Y equals 3 plus e to the x squared to the power of 4. Okay? You ready? So, what type of rule do you think is the overall? Never mind what's in the bracket. What type of rule is it? It's a chain rule because it's all contained within a power. So lads, this one here are both chain rules. These are chain rules here. Okay. This one here can be done by a chain or a quotient. This one here is a quotient rule. This one here is a product rule. Okay. Now let me show you the chain. 4 goes to the front. dy dx equals 4. Remember what happens with your chain rules. The brackets are always maintained. Now the tricky part is differentiating the bracket itself. Okay? Now, differentiating the bracket itself. When you differentiate 3, what happens? 0. Differentiate e to the x squared. E to the x squared survives. And what do we need to be concerned about? Differentiating the power, which is 2x. So this is what we have here. Now we're not quite done yet. Which part are we never allowed to multiply in by? This part here is completely safe. Why is it safe? Power to 4. Bomb that. You have to do your exponents before you do multiplication. You have to square stuff out first before you multiply. And let's be honest, we're not going to square that out 4 times. Absolutely massive number. So what we're going to get here is this. 8x e to the x squared 3 plus e x squared to the power of 4. Okay. Now that's done. That is question 18. A harder version, I think probably the hardest version here is question 19 maybe. Okay. Now, question 19, you have a choice of 2 ways to handle it. And I'm going to let you guys tell me which one you want to do. Okay. Connor. Okay. So guys, you have a choice of two ways of doing this, okay? The first way is like this. You could use a product rule where u equals 1 and phi equals 3 minus e to the 2x squared. The second way of doing it is to bring all of this up to the top and say y equals 3 minus e to the power of 2x squared to the power minus 1. You have a choice between a chain rule and a quotient rule. Hands up if you'd like to see the quotient rule. Hands up if you want to see the chain rule. Okay, we'll do it both ways. I'll do the quotient rule because I did chain rule last time. Okay, shh, grand. Okay guys, shh, excuse me. What we're going to do here is the following. What we're going to do is we're going to say if u equals 1, du dx equals, when you differentiate any number without the variable x, it turns to 0. Okay? Then we're going to have phi equals 3 minus e to the 2x squared. When you differentiate it, the 3 turns to 0. Now the e to the 2x squared is maintained, but we have to differentiate the power. Minus 4x e to the power 2x squared. Put it into your quotient rule. Quotient rule at this stage, we should know it off this stage. Start off with b. 3 minus e to the 2x squared times du dx, which is 0, minus 1 times the v dx, which is minus 4x e to the 2x squared, all divided by b squared, which is going to be 3 minus e to the 2x squared to be squared. We're not going to multiply at the bottom, absolutely no point. Multiply the top and we get 4x e to the 2x squared all over 3 minus 2x squared. Okay, now it's going to be e to the power of 2x squared to be squared. That's the derivative of that one. Okay, last one of the day. What did I forget? The number multiplied by 0 is 0. Okay guys, now 22 will be the last one I do for you today. Okay, now for number 22, it's quite easy enough. Okay, what you're going to do is this, guys. Okay, 22 is f of theta. It's the same thing as f of x, except there's a theta sign instead of an x sign. Now, what it says is differentiate once and replace x with theta with 0. Okay, so we're going to differentiate once. Now, it's going to be f dash theta is the first derivative. Please remember once again that the power is maintained. In the corner, differentiate the power. Now, when you're differentiating the power, what is 1 plus sine theta when you differentiate it, Connor? What does 1 differentiate into?
Yeah.
Sine theta? Cos theta. Okay, so it's going to be cos theta 1 plus sine theta. And now I ask you to replace it with 0. It's going to be cos 0 e to the 1 plus sine 0. What is sine 0, guys? 0. So it's going to be, and what's cos 0? 1. It's going to be 1 e to the power 1 plus 0. The 1 plus 0, this plus 0 disappears, and the answer is going to be 1 e to the power 1, which is basically just e. Okay? Second one asks me to differentiate twice. To differentiate twice, I'm just going to rub out the last part there. Now, Simon, you can see that there's two completely separate sections now. There's cos theta and e to the 1 plus sine theta. That's u and v. Second derivative, okay, is going to be differentiate. Sorry, the u d theta will be minus sine theta. The v d theta will be, the power is maintained. Oh, it's the same as last time, isn't it? It's going to be e 1 plus sine theta. I've already done it actually. Differentiate sine theta, you get cos theta. So it's actually already done from the first section. There it is there. The second derivative. So the second derivative is going to be cos theta times the v d theta, which is cos theta e to the power of 1 plus sine theta. Okay, now that that's done, and then it's going to be, that is cos times the v d theta. Now it's going to be v times the u d theta, which is going to be minus sine theta e to the power of 1 plus sine theta. Now look at this, guys. Plus minus is basically minus. You can get rid of that minus there. Now that's done. Replace everything with 0. So cos 0 is 1. This cos 0 is also 1. This is going to be e to the power of 1 plus 0. All of this part in blue turns out to be e to the power 1, or e. The part in red is going to be sine 0 is 0. So it just all disappears, and once again the answer is e. Okay guys, what questions did I do?